Hello everyone, I'm continuing to look at lead code problems, improving my interview skills and problem solving skills. Today I'm going to look at the valid anagram problem 242. It's in the arrays and hashing section. Given two strings s and t, return true if t is an anagram of s and false otherwise. At first, as usual, we need to understand the problem and ask clarifying question. Let me clarify the problem. First, we need to understand what the anagram means. If every character in one string are exact the same is the second string, it is an anagram of each other. For example, this is an anagram. I can ask clarifying question: do the strings consist of lowercase English letters? If it wasn't specified in the requirements. Also, I mentioned some of the questions that I might be asked, but I need to think about this ahead while, for example, I go through approaches, different solutions. After understanding the problem, I will jump right in and discuss approach. So the approach I would take is to use an array of size 26 to represent all the lowercase English letters. I will go through both strings once, and for each character I would either increment or decrement the count in the array. At the end, I would check the array. If all the counts are 0, the strings are anagrams. If not, they are not. It gives me of n time complexity since I'm just going through the strings once, and of 1 space complexity because the array size is fixed no matter how long the strings are. This is the best optimal solution for this problem if we have only English letters, not Unicode letters. Does this sound correct? I would ask. This is our array, an empty array of size 26. And when I go through the first array, I will increment the corresponding index. And when I go through the second array, I will decrement the corresponding index. And I will start writing the code and explain as I go. I will need a new function, public. We will return true or false. It means we will return boolean, and we will call this function isAnagram. We will accept two strings, s and string t. At first, I will mention one of the edge cases. I will check the length, because if the length is different, it cannot be anagrams. The second step that I will do is to create a new array of size 26. Let's name it char counts size of 26 because it's the exact number of characters in English alphabet. First, I will traverse the string. First, I will need to traverse the S string. I will do this with a for loop. Here we need to store the count of our characters in our char count array. We will access the character with the char at, and I will explain this line in a second. So why we're doing here minus character a plus, we need to look at the ASCII to understand the logic. We need to look at the ASCII table. ASCII table a is 97, and by doing that we will find the correct index for our character to place it in the array. So for example, ASCII character a is 97. 97 minus 97 equals 0. It means we need to place our character a in the first index. I will explain this in details when we will traverse the code with an example. And for the second one, when we traverse the second string, we will also subtract a, but in this case I will decrement the counter. And the last step will be to check our array if the array contains all zeros. N is not equals 0. It means we return false. Otherwise, we will return true. So this approach is a linear time of n time complexity and of 1 space complexity, because our array size is fixed. Let's walk through an example. I will take the smaller strings like red, which contains just 3 characters, red and car. These strings are not anagram. Let's check why. So the first step, we will check the length. The length is the same, so we continue to the next statement. The empty array is created of size 26. After that, we started to traverse the first array. I will look at ASCII table as well. So the first character in the first array is R. ASCII value is 114. 114 minus 97 equals 17. It means we need to increment counter in our array in index 17. The next one, 0, we increment here, 19, we increment here. Traversing this second string, we will need to decrement this counter. The same thing, C, look at the ASCII table. Actually, if A is 97, it means B is 98 and C is 99, obviously. 99 minus 97 is 2. The index is decremented here. It becomes -1. The second one is A, 0, and the last one 17, index 17. It was 1, now it's 0. And traversing the array, check if it all contains zeros. We see that output is false because it's not all the zeros. We have an index to -1, and index 19 has 1, counter 1. So what could be the edge cases? As I mentioned about the length, we handle this case and we return false. What if one or both strings are empty? We also handle these cases. If both strings are empty, it means it's true. And if one is empty, it's false because it's a different length. Let's look on one more follow-up question. For example, I might be asked, how would your solution change if the strings included Unicode characters? For this approach, for this solution, I will use creating a HashMap. I already have the code here. So what's different in this solution? I also would check the length of these strings. After that, I will create a HashMap to check the frequency of the characters in the strings. I will build the frequency map for the first string, and I will check the characters from the second string as well. This is how it would look like in the map if, for example, we will build the map for the red and for Anagram. For this approach, time complexity will be O of k, and time complexity O of n. But it has important note that worst case time of the HashMap operation can degrade if there are many hash collisions. That's pretty it. A little bit heavier on the second approach with the HashMap. I will need just to practice more explaining this on whiteboard. Thanks for watching.